We are back. So, part B, we're in section 4, chapter 3. We're still solving equations, only now we have moved into the realm of logarithmic equations. So, let me kind of give you some steps here. So, the idea, take for example the first question. You have log base 4 x plus 3, and that is equal to 2. Now, our directions are straightforward enough. They ask us to solve, meaning at the end of this, we want to make a statement about x. Well, how do we do this? So, the way that this is going to work is we're going to move out of logarithmic form into exponential function form. That's going to be our first step. So let's go ahead and just in case it's been a while, remember the base of the exponential function is written as a subscript for log. Remember that a log is always equal to an exponent. And then what's inside the log is what your exponential function will equal. Ready? So we've practiced the skills. Let's just jump in. So the base, what is the base in this problem? Well, for part A, the base is 4. And what is the exponent in this problem? Well, the exponent is 2. And this is equal to what? Well, what's left is what's inside the log, which is equal to x plus 3. Not bad. All we have to do now is solve for x. So 4 squared is 16. We'll take away 3 from both sides, and we end up with the statement x is equal to 13. Now, I'm going to go ahead and do part B for you the same way, and then I want to circle back and make a statement about solutions to logarithmic equations. Well, let's go ahead and get started. So, do you recall what is the base of ln, the natural log? Well, I hope so. We've covered it a lot, but the base for ln is e. So, okay. What I'm going to do is I'm going to go ahead and isolate the ln. So I'll start by dividing both sides of this equation by 3. And what does that leave me with? Well, that just simply leaves me with ln of 2x is equal to 4. All right. Back to exponential function notation. So the base, remember, base of ln is e, so it's base e. The exponent is the 4. And that is simply equal to 2x. Divide both sides by 2. You end up with x is equal to e to the power 4 over 2. And we're done. And now let me circle back to solutions to logarithmic equations. So indulge me for a moment. Recall, think back to when, say, you were in middle school, high school, and you would go through, let's say, an algebra problem, and you would work it out and you would get your answer, x equals 2. And do you recall your teacher always asking you to take your answer and plug it back in and make sure it works, right? Well, although that is a good practice for checking to make sure you got the right answer, there is actually something more structurally going on there. And the idea, really quickly, if you don't mind, in an aside, the idea is if you think about an if-then statement, right? If you were to say, if you live in Miami, then you live in Florida. Now that's a true statement. But if you were to switch that if-then part around, if you were to say, if you live in Florida, then you live in Miami, that is not a true statement, right? So an if-then statement, what we call a conditional, you can't it's not necessarily going to be a true statement if you were to switch it around, right? The antecedent, the consequent, to switch places. So you would have to check that. So a long story short, remember your teacher telling you to take your answer and plug it back in is a way for you to make sure that the if-then statement can be switched around. In other words, instead of being conditionally true, it would be biconditionally true. However, that's just the aside. Now, taking your answer and plugging it back in is no longer an option for logarithmic equations, because what I'm trying to tell you is you can do everything perfect. All of your algebraic techniques can be perfect, and you can end up getting extra answers that aren't really solutions. In mathematics, they're referred to as extraneous solutions, meaning you picked up an extra solution that's really not supposed to be there. It's really not a solution. So I'll show you what I'm talking about on the next problem. But until we start that, just the takeaway is you have to go back and plug in your answer. You have to. Because you could have done everything perfect, and then this is still not correct. Let me show you what I'm talking about. So we want to solve the following logarithmic equation. Take a look at the left side of that equation. You have log base 2 of x plus log base 2 of x minus 7. Now, do you recall how we could condense a log using those log properties? Right? You see it. We see our plus symbol there, right? So remember the product rule, where if you had, let me just do something really quickly. If you had log of m plus log of n is equal to log of m times n. We are going to use these properties that we learned in the previous section to our advantage to help us solve the equations. So let's go through and label. Let's just label xm. Let's label x minus 7n. And let's condense that log. So now we have log base 2. Remember, now it's m multiplied by n. So x multiplied by x minus 7. Okay, well, I'm gonna go ahead and distribute that x. So now we have log base 2 x times x is x squared, x times negative 7 is negative 7x, and that's equal to 3. All right. At this stage, what we want to do is since we've isolated the log, we want to turn that into the exponential function form, right? Remember, the b to the power of y is equal to x. We want to now go to that form. Ready? So the base would be what? It would be 2. And the exponent in this case would be 3, and this would be equal to x squared minus 7x. Okay, so remember, the goal is to solve for x. So let's go ahead, and 2 to the power of 3 is just 8. So let me rewrite it, and I'll kind of, while I'm rewriting it, I'll tell you what's going to happen here. So what we're going to do is we're just going to set this equal to 0. So we'll bring this 8 to the left side of the right side of the equation, and that would leave us with 0 is equal to x squared minus 7x, and now it's minus 8. Okay. So this, hopefully we're starting to recognize that's a quadratic. So we're gonna see if it factors. If it doesn't factor, remember, we still have that quadratic formula in our back pocket. We can always reach in and grab that if we need it. However, for this problem, we're not going to need it. This quadratic does factor. And what does it factor to be? Well, it factors to be x minus 8 multiplied by x plus 1. All right, and there's only one more step. So now that we factored, we're just simply asking the question, what must x be in order to make this entire equation equal to 0? Well, if you were to choose x is equal to 8, or if you were to choose x is equal to -1, either of those would result in a true statement. And now, can you agree that our work is perfect? Right? Assuming that I haven't made some trivial mistake that I haven't spotted, our work is perfect. We have not engaged in any error. Yet, one of these solutions is an error. One of these solutions is that extraneous solution that I was talking about. One of them doesn't work. And how would you know which one would work and which one would not work unless you tried them, unless you plugged them in? So I'll show you right now. The -1 is not going to work. Notice that if I take -1, as soon as I plug it in for x right here, do you see how you have a problem? You're taking a log of a negative number. That is a nonsensical statement. So it does not make any sense. It's restricted from the domain. So let's go ahead and do away with that solution, and as we can plug in the 8. I'm not going to go through this. You can on your own time, but this would work. You would end up with a true statement. So what is the actual solution to example 7? It's x equals 8. As I said, the checking of your work is no longer optional. You must do it. You must do it. So I got one more problem, and then we will conclude section 4. So hang in there, almost there. The game plan is the same. We want to solve, meaning we want to write x is equal to. All right. Well, let's see if we can condense this log. Well, I'm looking at this minus symbol, and I'm thinking, oh, that looks like a quotient rule. That looks like, if you have log of m over n, that's just equal to log of m minus log of n. Only we're going the other way. So, okay. So let's label. So this x plus 2, this would be m. This 4x plus 3 would be n. And here we go. So this is going to be ln of, well, it's m over n. So x plus 2 over 4x plus 3. Okay. So we haven't done anything with the right side of the equation yet. So I'll just go ahead and leave that alone. Now, so the final skill that you need is what's going to happen right now. So notice now you already have ln on both sides of the equation. And recall that I had mentioned to you that ln of e is equal to 1. It's also true, right? It's also true that e to the power of ln is equal to 1. So if I want to get rid of these ln's, what I'm going to do is I'm going to exponentiate both sides of this equation. In other words, instead of taking log of both sides, we're going to exponentiate e to the power of both sides. And as soon as we do that, the e to the power of ln's turn to 1. So do you see how that's a way of getting rid of the ln's? Okay. So that's what's going to happen right now. I'm going to go ahead and we choose a different color here. So this is the exponentiation that allows us to get rid of the ln's. And I'll write as an aside, e to the ln is equal to 1. Okay, so let's write what is left at this stage. So now we're left with x plus 2 over 4x plus 3, and that's equal to 1 over x. All right, well, the goal is still to get x by itself. So I'll give you a trick if you don't already know it. If you've never been a fan of fractions, you do know that there is a number out there that you can multiply by to get rid of your fractions, right? Well, if you just simply multiply both sides of this equation by the least common denominator, or even a common denominator, preferably the least common denominator, but that number will clear your fractions. You will be able to get rid of your fractions. So, what is that least common denominator? Well, when all else fails, just take this denominator multiplied by this denominator. In fact, for this case, that is the least common denominator. So x multiplied by 4x plus 3. So watch what's going to happen. So I'm going to get rid of this fraction. I'm going to multiply both sides of this equation by that LCD. Okay? So both sides of the equation are going to get multiplied by that least common denominator. And let's see if you can follow me here. So let's start with the right side. If you were to multiply that LCD times 1 over x, see how the x's would cancel? If you don't spot that, I'll just write it for you. X times 4x plus 3 distribute to the 1. That would be x times 4x plus 3 over x. Now do you see how the x's would cancel? And you're simply left with 4x plus 3. Likewise, distributing it to the left side of the equation, can you see how the 4x plus 3's would cancel? and you would just simply be left with an x. So let me write that. So you're left with x times x plus 2, and that's going to be equal to 4x plus 3. Much easier, right? We notice, listen, this is not magic, right? It's not mathematical magic. It's the same equation, just without the fractions. Okay, so now let's distribute our x, and then we just got to solve. So that gets us to x squared plus 2x is equal to 4x plus 3. Ready? Let's set the whole equation equal to 0. So I'll leave that x squared where it's at. Take this 4x and bring it to the left side by subtracting. So that's going to be minus 2x. And bring this 3 to the left side by subtracting 3. And now the only thing we have on the right side of the equation is 0. Beautiful. So that is a quadratic. Again, we're going to hope that it factors, but if not, we'll use our quadratic formula. The good news is it does. It does factor. So follow me up here. Let me write that in factored form. So that's going to be x minus 3 multiplied by x plus 1 equals 0. And now you got it. So x, what must x be? Well, if you were to choose x is equal to 3, that would zero everything out. If you were to choose x is equal to negative 1, that would zero everything out. And now comes the time where you must check. You must check to see if these solutions are actual solutions. It's possible one is a solution, one is not. It's possible neither are solutions. Okay, in mathematics, we can both be wrong, but we can't both be right. So, nevertheless, we go back, we plug in a 3. We want to see if we have any problematic statements. We go back, we plug in a negative 1. We want to see if we have any problematic statements. And guess what? The negative 1 is a problem. So the only solution is the solution of x is equal to 3. All right, so congrats. You now can solve logarithmic equations. You now can solve exponential equations. I will see you in the next video.